1, 2, 3. Little review. What about linears? Just one. Linears disco, and they only disco. So if linears disco, we have at minimum 1. We also have at maximum the degree. What's the degree of a linear? Degree 1. So at minimum it has 1 because it discos. At maximum it has 1 because it's degree 1. So it can have 1. That's it. Correct? Degree 2 is a quadratic. What's the maximum it can have? Degree 2. 2 is equal to the degree. For all of these, you've seen that. Degree 3, degree 2, degree 1, maxes out, right? What's the minimum a degree 2 can have? It doesn't disco. Pardon? 0. A degree 2 can actually have 0 because it has arrows in the same direction, correct? So it ends up, so it could have 0. It could also have varying levels in between. So it could have 1, and it could have 2. And then our 2 is our max, right? So 0, 1, 2. We agree? Even degrees can always have 0. But the only even degree we deal with is quadratics. So it's the only one that can have no x-intercepts. Right? Because it doesn't disco. All right. 2. Determine the following characteristics of the polynomial x cubed minus 4x squared minus 5. Okay, so your graph and my graph should look the same. If your graph looks like, first off, you didn't draw a graph, that's a problem. Second off, if your graph looks like you went over a speed bump while riding in a bus, that's another problem. If your graph doesn't have one accurate point off of your calculator, that's a problem. If your graph has only one accurate point, that's another problem. So it needs to be accurate and it needs to be drawn properly. So I want everyone to type in their calculator. We're not going to go through the whole entire polynomial simultaneously. You have to today, have to tomorrow. But we're going to go through what I expect on a graph. So everyone should be typing this into their calculator. You can pretend your calculator is like a cell phone and like you're playing a game right now. And it'll make you feel better about holding your calculator in your hand. This is called the graphing game. You're welcome. Okay, so we have a calculator in our hands. We have y equals, we have that equation, correct? If I want the x-intercepts, what's the fastest way to get the x-intercepts? How do you get the x-intercepts from your calculator? Yeah.
You can use the zeros function?
Yeah, you can go second trace 0, which is number 2, right? Not the actual 0. Left bound, right bound. You can do that, or what's another way you could do it? In your y2, you could put what? 0, and then find out where they intersect, correct? So this one has 1. Second trace 5, because I'm doing the intersecting. It's at 4.27 and 0. So I draw here, so obviously the person marking it knows that's 4.27 and 0, right? Because it's so clear. No, they don't. Now do they? Yes. The person who's marking it, you have to pretend doesn't know what they're looking at. You can't be like, oh, Miss Lepp, you know how to do math. You can figure it out. No, it's not my job to figure it out. My job is to mark what you put on paper. Right? Okay, so we know that this has how many x-intercepts? 1. What is the y-intercept of this graph? Something in -5. 0 and -5. Where did you get the -5 from? Because you're completely correct. The constant, right? The constant is our y-intercept. If the equation does not have brackets, we agree? As we get 0 and -5, so we're going to plot that. Now, because I made you such a small window, are we going to have the greatest graph known to man here? No, this graph's going to actually kind of suck. So what we would have to do if this was a test, they would either give you a plotted graph that fits everything, or more often than not, they give you completely empty blank spaces, right? And then you have to make a window that fits. And so what I get people doing is this one is plotted, so you have to do what it says, right? But when it's not plotted, I'll get people who plot it themselves and then they'll go like this. When in reality, the graph looks like this. And if they would have just changed their window, it would fit. We agree? So if they give you a blank space, you have to make the whole graph fit. You can't be like, oh, I picked it wrong. Okay, well, I'll just Or like, no, you can't, it's not like 3 separate lines. You have to make it look like it is. Okay? So this one's at 0 and -5. What is the end behavior? I'm not looking at the graph. How do you know it's up on the right? Positive leading coefficient tells me it's up on the right. I really shouldn't use an arrow because you're going to do what I did on the test. Up on right. So that positive leading coefficient tells you how it ends on the right for every single thing. Linear, quadratic, cubic, correct? Because this is cubic, I know it does what? What kind of damage? It discos, correct? If it discos, I know the arms are in what? Opposite directions. So I know it's up on the right because of the leading coefficient, but I know it's down on left. Why? It's down on left because they have to be in opposite directions because discos, right? If it's an even degree, so degree 2, the leading coefficient would tell me how it ends on the right, so up on the right, then I would know it also is up on the left because they're in the same direction. Do you agree? Okay. What's my domain? It's a polynomial and it's not a word problem. Right. So we use the squiggly bracket because it means the set of x values such that x is an element of the reals. And why did I use x? What's my variable for x? X. It's crazy. I know. Okay? If it's a word problem, we have to watch ourselves. It could be a restricted domain because we could be talking about time, let's say. Correct? And can time be negative? No. So you have to say greater than 0. Okay, number of turning points. That's maxes and mins. How many turning points are there? 2. What's the range of any discoing graph if it is not a word problem? Y such that y is now with the reals. But we have to go look and see what is our y actually in this equation. F of x, is it not? You see this? This is a what? An f of x, not a y, we agree? So it's going to be the set of, which is what the squiggly bracket means. Everyone's paying attention, right? So that you don't get this wrong on a test and put a y, and then I mark you wrong, and then you tell me I'm mean. This moment would be the reason why I'm not mean. I'm showing it to you correctly. It is not a y, it is an f of x. So we do f of x such that, that's what the straight up and down line means, f of x is an element of the reals. Because we do not have a, if you said y is an element of the reals, I would look at you and say, where are you getting a y from? There's not even a y in this equation. I love that y is an element of the reals, but remember, your range is telling you what exists for y, correct? So if you say y is every real number, I would say, cool, there's no y in this equation. And then you'd be like, yes, f of x is an element of all the real numbers. Because if there's not a y in the equation, you can't write y. Because there's no y that exists. All right. We're going to graph better on something else because this one kind of sucks. Okay, let's go here. The volume of water in a cylindrical tank. Now, these are the outcomes for this curriculum for this unit. Are you paying attention? What I needed to teach you for this unit, which I've taught you all this, I needed to teach you what a linear graph was, what a cubic graph was, what a quadratic graph was, right? I needed to teach you that the leading coefficient tells you how it ends on the right. I needed to teach you that the constant is the y-intercept because I can plug 0 in for x and it would give me that. I needed to teach you to give me the domain and range of linear, quadratic, and cubic functions, which are the polynomials that we're looking at. Polynomials is like the umbrella of what unit we're doing, and the polynomials we're looking at for this unit are linear, quadratic, and cubic. They're under the umbrella. There's quartic and quintic, which was degree 4 and 5, which is what we have to do with 30-1. We get to stop at cubics for you guys. So there are degrees that are way bigger than 3, but that's all I have to teach you. Okay, that's where we stop in 30-2. Now, the other thing I needed to teach you is how to be able to come up with a regression from data. I can give you data, and you have to be able to give me a linear, quadratic, or cubic regression. Right? That is what I have to tell you to do. So that's 4, 5, and 6 in your calculator. That was another curriculum outcome. So I can give you data, you have to give me an equation that answers stuff about the equation, or maybe just give me the equation, or maybe just give me the y-intercept. That was one outcome. The other outcome, the last outcome that we had to learn, was I could just give you an equation in a word problem. I can give you a linear equation, we did this yesterday, right? I can give you a linear, I can give you a quadratic, I can give you a cubic, which makes it a bit harder because windows are harder, right? When I don't give you an actual table of data. And then I can ask you anything about it. I can ask you for the y-intercept, the moment it was released. I can ask you for when it hits the ground. I can ask you for at time 7, what is the height? I can give you the height at 30 and ask you for the time. I can ask for the maximum height. I can ask for the time to reach maximum, right? Those are all the different curriculum outcomes for this unit. You have been taught it all, okay? You have to be able to make a restricted domain or range based on a word problem as well, which we've talked about too, okay? So where does this one fall? This one is the volume of water in a cylindrical water tank being drained can be modeled by the function v of t equals negative 3.8 t plus 225, where v represents the volume in liters. So it's volume in liters, and that's in y spot, correct? And then t represents the time in minutes, and that's in x's spot to help me out. That's what I would think. Because I need to know if I have to put in for, if they gave me an x, I need a y, or they gave me a y and I need an x. This is the last curriculum outcome I gave you. It's a word problem where I give you the equation, correct? And then ask you stuff about it. Okay? So here it says, how long, what am I looking for? Time or volume? Time. So I know I'm looking for a time of some sort in minutes. How long will it take for the volume to get to 0? So they gave me the volume, correct? They gave me v of t equals 0 liters. V of t is y, yes? When y is 0, what are they indirectly asking me to find? When you hear y equals 0, what should you immediately screen? X-intercept. And when you hear x equals 0, what should you immediately screen? Y-intercept. Remember, those are embedded in your brain. So if it says y equals 0, I'm indirectly asking you for the x-intercept. Yes? So we can do that one of two ways. We can either type this into our calculator and then find the x-intercept by doing second trace number 2, which is zeros. Or I can set y2 equal to 0 and find out where they intersect. Correct? So I want everyone to plug it in their calculator. I don't care if you got the answer already. You're trying it again because we're going to practice with our windows. Now, guys, I told you, always look at your y-intercept. What is the y-intercept here? 225. 0 and 225. So that means at time 0, the tank is filled up at 225, right? So how much does this tank hold at the beginning of this function? 225 liters, right? So we do know things. So we know that we're going to go to 0 liters, and then at least 225, that's where we're going to max at. So that's our window for our y. And then our x, we can go 0 to 10 and see if that's enough. We have to make it y. Okay? So trying it out, everyone's typing in their calculators and getting a window. Okay, cool. I put 10. Obviously, I can see the x-intercept. No, I can't. This is the craziest thing about Windows for you guys. You're like, okay, I'm going to increase everything. Do I need to increase everything? Do I see the top of the graph? Yes. Is it good to the bottom? Mm-hmm. Do I see to the left? Yes. So what's the only thing I need to increase? The right. So let's think about this. This increases your x min over here, right? Over here increases your x max. Here's your y min. Here's your y max. I need to go this way. So what's the only thing I need to increase? X max. And it looks like quite a bit to get down to the bottom, correct? So I'm going to go to my window and make my x max be 50 and see if that has helped. I'm getting closer. Still need to make it bigger. 75? Ah, I can see it. If I can see it, I can find it. Now, I'm going to make my y2 be 0 and find them intersecting because I like that better personally. Second trace 5. Enter, enter, enter. And I get 59.210526. And it says here, round your answer to the nearest minute. That's a whole number, correct? Nearest minute. So if it's 59.21 blah, 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 I go 59.2. I look at the 2. Is it 5 or higher? No. So I'm going to go to 60 or I'm going to stay at 59. Stay at 59. So I have 59 minutes. And then I'm done. It's a word problem. Am I done? I need a sentence. So I'm going to say it will take 59 minutes Guys, quiet please. For the volume. To get to 0 liters. Yes? Okay, when you have that done, you're going to flip over. Describe the characteristics of the trend. What kind of degree of function do you think this is? I think it's degree 1. I think it's linear, right? Trend as a function, trend in the data, it's decreasing. Sure. Decreasing is a little better, but yes, but you're the same. You could say, as your x's increase, your y's decrease. As your x's increase, your y's get, lower, but not negative technically, because your y's are actually positive. Yeah. Okay. We have to describe the graph of y equals x minus 3 squared. Is it helpful in the form it's in? No, so I'm actually going to expand it. So I'm going to go y equals x minus 3 squared. If I have a squared, I will cross off the squared and I will write x minus 3 again. To remind myself that there's 2 of them. And if you don't do that, you'll square the first term, you'll square the last term, and you won't have a middle term, which is the top. So whenever I have a squared, I write it out twice. I'm going to leave the x sit out front for now. And I'm going to FOIL the inside. So I get x squared. X times x, first times first, outside times outside, negative 3 times x is negative 3x. Inside times inside, negative 3 times x is negative 3x. Negative 3 times negative 3 is 9. So I get y equals x, collect like terms, x squared minus 6x plus 9. Now is it in the form I need? What did I tell you? In order to use the constant as the y-intercept, it needs to be in what? Y equals and no what? No brackets. So am I in the form I need right now? No, I still need to keep distributing. So, we'll put the x through. Y equals x cubed minus 6x squared plus 9x. There's no constant. There's no number without a variable, right? That's the constant. What can I put there if there is no number without a variable? Yeah.
Plus 0.
Plus 0. Exactly. So now can I get my y-intercept? Does the equation have brackets? No. So my constant is my y-intercept. So this here is my y-intercept. So my y-intercept, when I hear y-intercept, I think what? X equals what? 0. So I'm going to get 0, 0. For all of you feverishly typing this in your calculator right now, you have your y-intercept and your x-intercept. What's one of your x-intercept? 0, 0. If you have anything that's 0, 0, it is an x and a y-intercept. So let's type it in. How do I know if I'm right? Watch this. Everyone paying attention, put your pencils down. If I type the original in, x minus 3 squared, and then I type in my new one, which is x cubed minus 6x squared plus 9x, technically plus 0 if I so choose. If you have the calculators that does not have a color, I would suggest that you go over here and click enter and make it thicker. The reason why I say that is the graph should draw on top of itself, yes? If they're both thin lines, you won't see it. So you'll have one graph drawn, and then you'll be like, I think the other one drew on top of it. When in reality, the other one could have drawn itself off the graph window that you have, and you would never catch yourself, correct? If you make the second one thicker, it'll draw the first one thin, and then it'll draw the thicker one over top of it. Mine are colored, so it'll draw the first one blue, and the second one red. And I'm going to go zoom 6 to set it back to my standard window. So you see how it drew it on top of each other? If you have them both as thin lines, it'll draw a thin line and then a thin line over top, and you'll never know which drew the other one. So that's why I always make it thicker. All right, let's answer some questions. So we do have an x-intercept at 0, 0. Then It looks like we possibly have two other x-intercepts. So I'm going to go second trace intersect, which is 5. Enter, enter, enter. Oh, it's intersecting with itself. I have to take one of these off. Okay. Second trace 5. Enter, enter, enter. 0, 0. Second trace 5. Watch this. I know it has 2 at 3 because of the actual equation itself, but watch. If I use the y equals 0, it'll keep popping itself off of it. And you even doing second trace 2, watch this. Second trace number 2, if I go left bound, right bound, it'll actually get me the answer if it's actually on that. Second trace, when you put the y2 equal to 0, it won't get you the x-intercept on the other one. So it isn't foolproof making it that one. The second trace number 2, zeros, will always get you the x-intercept. All right. So this one is 3, and there's 2 of them there. How do I know that? Look, I have x minus 3 and x minus 3 and 0. So I have an x-intercept at 0, 3, and 3. So 3, 0. Do I have mins and maxes? I already have the minimum. It's at 3, 0. But I can check it anyways. Second trace maximum, which is 4. Left bound. Enter, right bound. Enter, enter. It's at 1 and 4. So that's a maximum. And then I have a min. Don't short form on a test, write minimum. It's your notes, so you can write short form. Second trace minimum. Left bound. I'm off the thing. I don't know what I just did. Second trace minimum. Left bound. Right bound. It's at 3, 0, which is actually the x-intercept. Your minimum is the x-intercept. And then it wants domain and range. Great thing about this equation, it's a cubic. What's the domain and range? It's disco, so it's XER, YER. Whenever you have a disco and it's not a word problem, it's XER, YER. Is it actually x and y? Does the equation have x's and y's? Yes, so it's even better. So the domain is x such that x is now under the real. And the range is y such that y is now under the real. Okay? We're going to work on the rest tomorrow. We're going to start exponent. We're on page 4. We need exponent laws for this one. So, last time you talked about exponent laws was mainly in grade 10. A little bit in 20-1, and a tiny bit in 20-2. But you all talked about it in grade 10. All right. So here, we have simplify the following. We have x squared times x cubed. What happens when we have two bases that are the same and two exponents? What do we do with those exponents? Do you remember? Add them. That is true. So we're going to get x to the 5. What happens when you have two of the same bases, two exponents, and you're doing division? Subtract. So we get x to the 4. So this is the difference between adding and multiplying. When you have two bases that are the same, two exponents, you add. When you have one base and two exponents, what do? Multiply. So now we're going to get x to the 20. This is the difference. This one is the multiply. One base, two exponents. This one is the add. Two bases that are the same. You can only add if they're the same base. Okay, this one. Let's remember to distribute our 3 through. So we're going to get x to the 3 over y to the 6. Now this one is where the error happens. Everyone will tell me that this is 3x to the 6, which is wrong. Where does the 3 have to go to? The x, but where else does it have to go to? the 3. So we're going to get 3 cubed x to the 6, and 3 cubed is actually 27. We're going to bypass quite a few of these because we did more polynomials today than I was going to do. So I want you guys to try this one. So here we have a to the 7, because we add. Here we have x to the 2, because we subtract. Here we have b to the 6, because we multiply. Here we have to distribute, so we get x to the 4, and then 2 to the 4, which is 16. And then here I have to distribute the 5 to both, so I get 2 to the 5, y to the 5. 2 to the 5 is 30, 2, y5. Okay. Should I box all the rest of the answers? We're bypassing this for time constraints. Flipping over. Okay. We're going to here. We're really bypassing a lot. All the grade 10 math, you just learned it. It's there. Good review. Solidly gave you the tiniest review ever. That's it. Okay, so what we are going to do is we're going to learn how to make a common base, right? Everyone's paying attention? So we need to make common bases because that's how we're going to solve today. So a common base means the same base. We're practicing how to make something into a different base. So we have 9 to the 2x, but I want it to be base 3. Currently, it's base 9. Whatever is below the exponent is called the base. So currently it's base 9. I want it to be base 3. So how do I make 9 from base 3? 3 to the what? 3 to the 2. So the only way you can make a common base is by finding that number to an exponent. Some people are like 3 times 3. True, but I need it to be 3 to some power. So 3 squared, we agree, is 9. True? Too much talking. Not enough paying attention. You'll be lost, little souls. All right. 3 squared is 9. We agree? Okay. So if I have 9 to the 2x, can I not take this 9, rip it off the board, throw it across the room, and replace it with 3 squared? Because they're the same thing. 3 squared is the same as 9. Do we agree? Everyone agrees with that statement? So if I want 9 to be base 3, I have to replace the 9 with something base 3. So 3 squared to the 2x. Now when I have one base and 2 exponents, this is why we didn't need a whole heck of a lot more rules. When I have one base and 2 exponents, what do I do with those exponents? Multiply, times them. So I get 3 to the 4x. Done. Now 9 to the 2x is actually the same as 3 to the 4x. They are the same. They are equivalent. All right. 125, I want to be base 5. Base 5. So I'm going to go, in order to be base 5, it's either 5 to the 1, 5 to the power of 2, 5 to the power of 3, 5 to the power of 4, 5 to the power of 5, 5 to the power of 6. And I do that until I get 125. Go. 5 to the power of what? It's 125, yeah?
When you move to 2x and why didn't you multiply the 2 or like square root of 3?
Sorry?
Because like the practice right there, it was if you have like numbers out, then you like put it into like even the number.
You have one base.
Yeah, that's what I was thinking.
The base is 2. The previous one, it was 3, and then an x, and then y. This is the base. This is 3 squared. Your other one you were looking at, the other one you were looking at was like 3xy to the 2. Then that would go to the 3, that would go to the x, that would go to the y. This is 3 to the 2, pretend xy. Right? The 2 would join the 2, then that would go to here, that would go to here. Because the 3 is squared. The 2 is on the 3. It's not like it's 3x squared. This is 3 and 2. This is one number. This is the number 9. So it just joins the exponent. you are applying it to the 3. There are no variables on this thing. Okay? All right. 125 is 5 to the what? 5 to the 3. So we agree that 125 equals 5 cubed. Yeah? So I can take the 125 off the board, I can huck it across the room, and I can replace it with 5 cubed. So I get 5 cubed instead of 125, and then outside I have 2 minus x. And I put in brackets so I remember to do the whole thing. Okay? 1 base, 2 exponents. What do I do with the exponents when I have 1 base, 2 exponents? Multiply. So I'm just going to have to distribute. Boom, boom. So I'm going to get 5, 3 times 2 to the 6, and 3 times negative x minus 3x. Done. Okay. The next one, we have 8 times 16x, and we want it to be base 2. Now, I can't make the 8 and 16 join the way they are, because one's an 8 and one's 16, and I can only make exponents join when they're the same base. Correct? So we're going to have to make them both be base 2. So I need to make the 8, these are multiplied, correct? I need to make the 8 be 2 to the something. What is 8? 2 to the what? 2 to the 3. Some people are like 2 times 4. Very nice, useless, but that's a true statement. 2 times 4 is 8. It's useless in this instance. We have to go base 2 to some power every time. And 16 is 2 to the what? 2 to the 4, and then I still have the x up there. Yes? Now when I have 2 bases that are the same and 2 exponents, what do I do with the exponents? Add. 2 bases that are the same, 2 exponents I add. Because when I had 1 base and 2 exponents, I multiplied. So 2 bases, 2 exponents wouldn't be multiplied because it's totally different things, right? One has to be added, one has to be multiplied. 1 base, 2 exponents, multiplied. 2 of the same bases, 2 exponents, add. So I'm going to get 2 to the 3 plus 4x. 3 and 4x are not like terms, correct? So I'm done. Okay, we want to make this one be base 2. We're going to leave the 1 be a 1. 512 is 2 to the what? 2 to the what is 512? Yeah. 2 to the 9. So we're going to replace this 512 with 2 to the 9. And then a 3x out here. What do I do when I have 1 base, 2 exponents? Yeah.
I'm just wondering for the last one, why, if you're joining 3 and 4x, why that's not a 4?
Pardon?
Like when you...
Because you can't put them together unless they have the same base. When you have a to the 2 times a to the 3, we say it's a to the 5, don't we? We don't say it's 2a to the 5.
Yeah.
Right? So the only way you can put together is if they're the same base, you rewrite the base. See? Once again, tsunami. All right. Does that make sense?
Yeah.
So when it's a number, you have to watch yourself because people will try and make it be a 4. But variables, they'll usually leave it. Numbers, they'll try and make it put together.
Okay.
Every time. Good question. Okay. So here I have 1 over 2 to the 27x. Now this is where grade 10 got a little dicey. If I want to move something from the denominator with an exponent to the numerator, do you remember what we do? So if I want to take this whole thing, and I want to move it up here. You're saying you're 12, I get what you're saying. We will flip it, but we have to change that one. Your exponent turns negative. So I want to bring this up here. I'm going to get 2 to the negative 27 over x. Okay, a lot of you aren't going to believe me on that. So I'm going to show you something with actual mathematics, with numbers, so you believe me. Okay. Let's believe Mrs. Lepp. So I give you 1 over 4. What is the answer to that as a decimal? 0.25. If what I said is true, I can take 1 over 4. 4 is to the 1, technically, right? Anything is to the power of 1. If what I said is true, if I want to move this 4 up, what could I raise this to the power of? 4 to the negative 1. Type that in your calculator. Type 4 to the negative 1?
Yeah.
0.25. So it's real. I didn't just make it up. Okay? So if you want to take anything from the denominator and move it to the numerator, it just changes symbol. So if it's negative, it'll become positive. If it's positive, it'll become negative. If you want to move something from the numerator to the denominator, same thing. If it's positive, it'll become negative. If it's negative, it'll become positive. Just change the sign. All right. Let's go back. Last one we're going to look at. 16 and 81. I want it to be a base 2/3. So I have to figure out 2/3 to the what gets me 16 over 81. Could I just deal with the 2 first? Could I say 2 to what power gets me 16? Go that route. So 2 to what power gets me 16? 4. So I'm really hoping that 2 over 3 to the 4 gets me 16 over 81, correct? I'm hoping that the 4 works with both of them. If it doesn't, I can't do it. So let's try it out. 2 to the 4 is 16. 3 to the 4 is 81, right? So those are the same things, are they not? Do we agree? So then I can replace it. So if I have 16 over 81 x plus 5, I can replace 16 over 81 with, that looks like 87 there. Oh, come on. I can replace 16 over 81 with 2/3 to the 4. So I'm going to get 2/3 to the 4, and then outside of that is x plus 5. Then distribute through. I get 2/3 to the 4x plus 20. What does this say? Your turn. Go. So 32 is 2 to the what? 32x. 32 is 2 to the 5x. So it's 2 to the 5x. 1,000 is 10 to the what? So if I have 1,000 to the 2x plus 1, 1,000 is the same as 10 to the 3 to 2x plus 1. I put the 2x plus 1 in brackets so I remember to distribute. So I'm going to get 10 to the 6x plus 3. Now I have 81 to the x minus 2. 81 is the same as 3 to the what? 3 to the 4. And that's the x minus 2. Like I said, if my exponent is not a monomial, it's just about broke an ankle, it's fine. Didn't though. It's close. If it's not a monomial, if it's a binomial or larger, please put in brackets. Okay? So we're going to get 3 to the 4x minus 8. Okay, this one, 1 over 64, I'm going to make 64 be 4 to the what? To the 3? The 2x. So I'm going to get 1 over 4 to the 6x. Or they could write it as 4 to the what? Negative 6x. Both of these are correct. So we're going to flip over. Okay, and make these be base 2. Now, this one is 2 times 2 squared with an x. People will get this wrong if they don't put an exponent on it. 2 is 2 to the what? 1. So when I have one out here, I always put a 1 on it. So now we actually have 2 to the 1 times 2 to the 2x, which is not actually 2 to the 2x. It's 2, same base. What do I do with the exponents? Add them. So I get 2x plus 1. A lot of people will forget the plus 1. If you forget the plus 1, do you think that answer is going to be on the diploma? Yep, common error. Remember, 1 right answer, 3 common errors. That's always what your diploma will be. So, I think it's funny to be like, well, that's me. Well, what else should the 3 answers be? Cat, dog, puppy, and then 3 to the 2x plus 1? They're going to have to be common error. They wouldn't make sense to put down, right? If it just makes sense, it'd be common error. Okay. So 9 is 3 squared. 27 is 3 cubed. And I put x minus 1 in brackets so I remember to distribute. So I'm going to get 3 to the 2 times 3 to the 3x minus 3. And then I get 3 to the 3x. I'm writing them out of order, which might confuse people right now. I'm going to write it in order. So same base, add exponents. So I get 2 plus 3x minus 3. And then I collect like terms. So I get 3 to the 3x minus 1. And then this one, they want you to make base 4. I'm going to deal with them the way they are currently. But if I want a fraction to flip, what do I just have to make it be? To the negative 1, right? So I actually find it easier if I just flip them right away and make them negative. That's what I'll do. You can keep them. But I'm going to go 4 to the negative 1 times 4, or that's not 4, that's a 16. Crystal, grab a minute. Get in the game. Okay, 16 to the negative 1 to the 4 minus x. And then I'm going to distribute that through, don't know why I made the mess. Oh gosh. All right. So we're going to get, I'm going to get 4 to the negative 1, and then 16 to the negative 4x, or negative 4 plus x. Then I can make them be base 4. So I make them be not fractions right off the bat. It makes it easier for me to see it. And now I can make them be base 4. 16, this one already is base 4. 16 is 4 squared. The negative 4 plus x. So I get 4 to the negative 1, and then 4 to the negative 8 plus 2x. And what do I do when I have same bases? What do I do with the exponents? Add. So I'm going to get 4 to the negative 1 plus negative 8 plus 2x. I can collect like terms. So I get 4 to the negative 9 plus 2x. Okay. Why are we doing this? We're doing this for an actual lesson. This is not actually the curriculum outcome. The curriculum outcome isn't make some same bases. But if we can't make some bases, we can't actually solve by common base. So I've set you up so that you can actually do the curriculum outcome. The curriculum outcome is solving for a variable in the exponent. Have you ever had a variable in an exponent yet? Like, you've only had like 3x plus 7 equals 8. Then you just get your x by itself, right? Worst case, you've had 3x squared minus 4x plus 6. You have to factor it and solve. But what you have not had so far is a numerical base with your variable in the exponent. How the heck do you deal with that? Well, one of the methods is by common base. So let's look here. This one says solve. Now, if it says solve, I don't care what unit you're in. I don't care what math course you're in. If it says solve, it wants variable equals a number at the end, because that's what solve means. So if it says solve ever, it wants variable. And why do I say variable? Because the variable could change. You guys are like, it's always x equals. It doesn't have to be. It could be t's, it could be p's, it could be n's, right? We need variable equals a number and then boxed. That's what they're looking for when the word solve comes along. Now, why do I love the word solve? Because you can always check it. If ever it says solve to you, you should always be able to walk away from the question, like I say to you all the time, happy or crying. There should be no in between. Happy, you plugged it back in, left side equals right side. Crying, you plugged it back in, and left side didn't equal right side, you know you got it wrong. That's it. There should be no in between when it says solve, right? Because when you solve, you're finding out what a variable equals, which means you can plug it back into the original question and see if left side equals right side and be happy. which hopefully you're always happy and not sad. But there is no in between. You don't just solve, find out what x equals, and send it and hope for the best. We don't send it on these. We actually put it in and see if we're right. Okay? All right. So here it says solve the following exponential equations. Where is the x in the exponent? Does anyone know how to do that? Reverse bedmass? Do I just like divide it over and then like add something? No, you can't do bedmass to get rid of that. One of the methods that we can solve when there's a variable in the exponent is by making common base. So everyone put your pencils down. I need you to understand this concept. Ready? It's intense. Okay? If I can get you to understand this basic concept, I can get you to do common base very, very easily. Yeah? I think you know the answer, but you're just I think you know the answer.
You want the answer?
Yes. Happy face equals 7 is what Harvey is saying is the answer. And Harvey is correct. Did I get to pull that happy face out of the exponent and solve for it? Is it now in the exponent anymore? No, I got it out of there. How did Harvey solve this? Well, he said that if this is 5 to the smiley face, and this is 5 to the 7, and this is a true statement, this is equal, then this must equal that. Correct? So let's try again. 5 to the pig. It's really good. I'm going to give him shoes. It's a pig. It has the nose. That was the giveaway in the curly tail. How did you mess that up? Okay, it's a pig. You now know. It's got shoes on. It's a walking pig. And I give you 5 to the 16.7394 pi. What is pig, not cat, equal? 7394 pi, right? If this is a true statement, then this little figure has to equal that little mark, that exponent. Is that a true statement? Yeah. You understand that? These questions are really easy. Okay? So if I can get one side of an equation to be 5, base 5, and the other side of the equation to be base 5, then I can set the exponents equal. Can I not? Right? So if one of my bases, showing you all my artistic abilities here. One of my bases is a Christmas tree, and the other base, pretend it looks the exact same as I'm going upside down. The other base is a Christmas tree, and they're the exact same, pretend, because that's just terrible. I did really well, and then it went downhill. And this one is to the 7, and this one is to the x. X equals 7. Is that true? As long as those two bases are the same, 5, Christmas trees, piggies, I don't really care, then those exponents must equal if that's a true statement. We agree? So let's go back. This one, I have base 5. I'm going to highlight it in this color. I have base 5. I have base 5. Just like having two Christmas trees, correct? If those are both base 5, what can I say then about the exponents? 2x plus 3 must equal 7. You're right. If those bases are the same, then I have to say that these must be equal. True? So let's do that. So 2x plus 3 must equal 7. So if I can get a common base on both sides, it's really easy after that. I can just set those exponents equal. Now I'm back to grade 7. How do I solve it? Minus 3. 2x equals 4. Back to still in grade 7. How do I get the x by itself? X equals 2. Box it, send it, hope for the best. No. We always plug it back into the typed question. So the question that Mrs. Lepp or the government typed for you, that is what you're going to put it back into. You're going to fill it in, get what the left side equals, fill it in, get what the right side equals, and if they equal the same thing, we're happy. So let's see. This is my check. So I'm going to plug 2 in for the x's. I'm going to get 5 to the power of 2 times 2 plus 3 equals 5 to the 7. What's on the left stays on the left. What's on the right stays on the right. Nothing crazy here, right? Then we have 5 to the 4 plus 3, 7, equals 5 to the, holy smokerdoodles, I'm a genius, I know I'm right, I walk away from this question being like, I at least got one question right on the test. Okay? Yay. So I like solving questions. You can check them to be happy or sad. There's no in between, right? There shouldn't be an in between unless you're sending it. Okay, what's the problem with B? Not the same base. But is there a number that I can make both of them B? 7, let's try it out. 49 is 7 to the what? 2. 7 squared. And that's to the x minus 2. And 343 then has to be 7 to the something. Like if I can make one be 7 and one be 5, it's of no help, right? They need to be like Christmas tree, 5, 5, 7, 7. Piggy, piggy, you know? So 343 is 7 to the what? 3. Okay, let's distribute through. So we get 7 to the 2x minus 4. The error in these is going to be that you forget to distribute that 2 to the next term. I'll get people giving me 2x and minus 2 instead of 2x minus 4. You see how they'll forget to distribute? That happens way more than it should. So I'm going to get 2x minus 4, bless you, equals 7 to the 3. Okay, let's get our highlighter out here. Bless you. I have a 7 as a base. I have a 7 as a base with an equal sign in between. So then what can I say? I pressed green. Oh no, this is going to be bad. It's going to, nah. No, it didn't. 2x minus 4, usually they mix. 2x minus 4 and 3 should be equal. Yes? So, we have 2x minus 4 equals 3, and then we're back to grade 7. Add 4. 2x equals 7. Divide by 2. And x equals 7 halves is acceptable. And 3.5 is also acceptable. Why is a decimal acceptable in this instance? Because it terminates. It stops. I didn't round anything, correct? If I had a fraction that I'd have to round the decimal, like 1/3, and I go, oh, 1/3 is equal to 0.3, no, it's not. So if you have a not terminating decimal, you have to write it as a fraction. But if it terminates, 3.5 is fine. So let's check it. So we're going to check. We're going to go 49 to the 3.5 minus 2 equals 343. And we have 49 to the 1.5 equals 343. And then 343 equals 343, and I'm happy. For C, what base can I make them both be? I have a 3 and an 81. We never make them bigger bases. We always make them smaller bases like we did in all the rest of the questions. So we're going to make it be 3. So 3 is already good. That one's done. So we have 3 to the 5x minus 1. And 81 is 3 to the what? 4. So I'm going to get 3 to the 5x minus 1 equals 3 to the 12x. Do I have my bases the same? Yeah. Can I highlight them? Yes. This is a 3. This is a 3. So then I can say that this has to equal that. Right? Five x minus 1 equals 12x. Subtract 5x. Negative 1 equals 7x. Divide by 7. X equals negative 1/7. And then I have to check it. So I go 3 to the 5 times negative 1/7 minus 1 equals 81 times 3 to the negative 1/7. I'm getting 0.15289, blah, 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 blah. And then I do the other one, 3 to the power of 5. That's it. Same decimal, right? It's 0.15208201118. Okay, for homework, I want you to do up to I. Actually, skip G for now, because I'm going to show you that one tomorrow. So I want you to do A, B, C, D, E, F, H, I. Okay? Keep working.
I saw somebody.